Okay, let's talk about TEAC 6.3b, which is determining when a quantity is increased or decreased when multiplied by a fraction, both by computation and by just looking at the fraction. So to begin with, I'm going to have a problem here. Mr. Baker has a goal. All right, I want to get all the vitamins I need to get over my cold by drinking one full glass of orange juice every morning for breakfast. If I do this for 5 days, how many glasses of orange juice will Mr. Baker drink? Okay, so that should be a pretty easy enough problem. I can draw my model here. I'm going to have 5 glasses of orange juice because I'm going to drink one every day, right? So this is day 1, day 2, day 3, day 4, and day 5. Okay, so if I drank the entire glass of orange juice, that's going to look like, maybe this is cranberry juice. I don't know. I have a red marker. Then clearly at the end of 5 days, I will have drunk 5 entire glasses. Right? So I could write this as 1 glass of orange juice, right, times 5 days equals 5 glasses. And actually, I'm going to go ahead and I want to write that out. I'm going to write my words. So 1 glass per day, right? 1 glass per day times 5 days equals 5 glasses. All right. Okay, easy enough, right? 5 times 1, 1 times 5 is 5. Okay, now let's change the problem a little bit. Oh, there's my cold again. If I want to drink less than a whole glass a day, okay, so maybe I don't drink 1 glass a day. Maybe I only drink 2/3 of a glass. So here's my question. You can think about it for a second. If I don't drink the full glass of orange juice or cranberry juice, whatever this is, if I only drink 2/3 of a glass, what will happen to my total that I've drunk over a week? Will it be more than 5 or less than 5 glasses over the whole week? Well, clearly it's going to be less than 5, right? If I don't drink the whole thing, if I only drink 2/3, and I do that for 5 days, we can automatically know that it's going to be less than 5, right? Because I'm drinking less than a full glass every day, right? So I'm going to end up drinking less than 5 glasses. And the way this changes my problem here is I'm not drinking 1 glass every day. Now I'm drinking 2/3 of a glass, right? So I could write this like this as a fraction, 2/3 of a glass. Now this is kind of interesting. We'll get into later when we talk about rates. But in fact, drinking 2/3 of a glass in one day is the same thing as drinking 2 full glasses over the course of 3 days. You can see that if I take all my boxes in these 3 days and I put this cube right here and this one over here, I'll have drunk 2 full glasses in 3 days. But it's going to be the same thing. My fraction is now 2/3 instead of 1/1. Now it's 2/3, right? And you can tell just by looking at it that this is going to be less than 5 glasses, right? Okay? I'll have drunk less than 5. And I can actually do the multiplication to see how much it is. So let's try that out. So if I drink 2/3 of a glass every day for 5 days, I could just multiply these, change my whole number into a fraction by putting it over 1, and then multiply straight across. So I will get 2 times 5 is 10, and 3 times 1 is 3. So that's 10/3 of a glass. And in fact, you can see that on my picture, right? If I count my thirds of a glass, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10/3 of a glass of orange juice, right? And again, we can convert that into a mixed number simply by taking your half full glasses and dumping them into these ones until they're filled up. So I can take this last glass. If I pick up this glass and I pour it in this one, it's going to lose one of these thirds, and it's going to fill up this glass. Right? And likewise, I could dump out the rest of this into this cup. I could dump out this one into this cup. Right? And so I'm left with 10/3 is the same thing as 3 full glasses and 1/3 of another glass. Right? So that's the same as 3 and 1/3. And you can do that in a shortcut because 10 divided by 3, 3 goes into 10 3 times. That's this 3, with a remainder of 1. Right? And then you can work backwards because 3 times 3 is 9 plus 1 is 10. Okay, let's take a look at another example. So we've seen that this is definitely, 3 1/3 is definitely less than 5, right? We said it was less than 5. Well, of course it is. 3 1/3 is definitely less than 5. So now let's take a look at another example, all right? So instead of drinking 2/3 of a glass every day, now, Mr. Baker, let's switch that. Let's take the reciprocal of 2/3. So the reciprocal of 2/3 is, just as a review, reciprocal means flip it. Okay? So just for fun. Now, Mr. Baker goes in his doctor's office. The doctor says, you're not drinking enough. Now I want you to drink 3/2 of a glass of orange juice every day for breakfast. So that's going to look like this, right? Every day I'm going to drink 3/2 of a glass. So I'm going to drink the whole glass and then another half, right? That would be 3/2. 1/2, 2/2, 3/2, right? Which is the same thing as 1 1/2. So if I do this for 5 days, let's see what it is. This is 1 day, right? And I'm going to do that 5 days. 1, 2, 3, 4, and day 5. Okay, so the question is this going to be less than 5 cups of orange juice, greater than 5 cups of orange juice, or exactly 5 cups of orange juice? Well, clearly it's going to be more than 5, right? Because I'm drinking more than 1 glass. I'm drinking 1.5 glasses every day. So just by looking at my picture, or by looking at the fraction 3/2, I know it's going to be more than 5. If I'm drinking more than 1 glass, I'm drinking 1.5 glasses. And if I do the actual multiplication, I can figure out what it is exactly, right? It's going to be 3/2, that's what I drink every day, times 5 days. Which again, I can make 5/1, multiply straight across. I get 15/2, which if I divide, or if I take my actual pictures and fill them up, comes out to be 7 1/2 glasses of lemonade, or orange juice, or cranberry juice, or whatever this is, right? Which is definitely greater than 5. Okay, 7 1/2 is definitely greater than 5. So there it is. Now, let's take a look at those fractions. So if I multiply a number, say 5 days, by exactly 1, I'm going to end up with the same thing I started off with. If I multiply a number, say 5, by something less than 1, like 2/3, I'm going to get less than 5, right? And if I multiply 5 by something bigger than 1, say 3/2, I'm going to get something bigger than 5, that makes sense, right? If I drink a full glass, it's going to be 5. If I drink less than a glass, it's going to be less than 5. If I drink more than a glass, it's going to be more than 5 over 5 days. Right? Makes sense. Okay. So let's think of another way. This is just introducing some more terms you've learned about before. Improper and proper fractions. Right? So an improper fraction, remember, is a fraction in which the numerator is greater than the denominator. The way I remember it is, it would be proper for me to give my son a piggyback ride. Right? That'd be okay. Okay. That would be proper. It'd be improper for my son to give me a piggyback ride. So if the numerator is smaller than the denominator, which it is in this case, 2 is smaller than 3, that is called a proper fraction. So this is a proper fraction, because it's proper for the small one to be on top. If, on the other hand, the numerator is bigger than the denominator, this would be an improper fraction, because the denominator is smaller than the numerator. So in general, we could say that if you multiply a number, say 5, times, let's say I'm going to put n for number, okay? N for any kind of number. Actually, let me change that. N for any kind of positive number. Okay. If you multiply a positive number times an improper fraction, you're going to get something bigger than that number you started with. Okay. Any improper fraction. That could be 3/2, that could be 4, that could be 18 million. Those are all improper fractions, right? 18 million over 1. Any improper fraction, any number bigger than 1. Or as I like to think of it, as improper fractions increase the number, right? Improper, increase. Whereas if I multiply any number times a proper fraction, it's going to be less than the number. It's going to be less than what you started off with. And again, this, what I mean by any number is any positive number, right? So any positive number times a proper fraction gives you a number that's less than the number you originally started off with. So proper numbers decrease. Okay. So improper numbers, when you multiply it by a number, it increases it. Proper fractions decrease it. And that's all you got to know about this one. So I'll have some sample problems up here you can do. But that's pretty much it. It is literally as simple as looking to see what your fraction is, whether it's proper or improper. And then if it's proper, it decreases. If it's improper, it increases. Done. What if, however, if your fraction is equal to 1, which some fractions are, like 12 over 12, right? If your numerator is the same as your denominator, your fraction is equal to 1. In that case, your number ends up exactly the same as it was, because 1 is what we call the multiplicative identity. Anything times 1 stays the same as it was. Okay? And that's it. See you for the next.